Hey there, focused learners and Year 5 scientists. Welcome to the super fun, high-energy explainer. Today, we're going on an electric adventure. I am absolutely pumped to dive in with you and unlock the invisible world of electricity. It's the stuff that powers literally everything around us, from the tablet you're watching this on right now to the lights right above your head. It kind of seems like magic, right? But it's not, it's science. So, to kick things off, I want you to think about a real-life mystery. Have you ever noticed how sometimes an entire string of holiday lights goes completely dark just because one tiny bulb breaks? But then, at the exact same time, you can turn off the light switch in your bedroom and your TV stays on perfectly fine. Like, why doesn't your whole house go dark when you turn off one switch? Well, today we're going to solve this exact mystery together using the amazing science of circuits.
Here's our adventure map for today's explainer. We'll start by powering up with energy sources, meet the circuits with Sparky's path, take the brightness test, look at broken circuits, cover smart energy and home safety, and finish off with a really fun circuit quiz. All right, section 1, powering up. Where does electricity come from? Electricity comes from so many awesome places. For example, we've got solar cells. These literally take light energy straight from the sun, solar energy, and turn it into electricity to power things like your calculator, or even giant satellites floating up in space. Then we have dry cells. You probably just call them batteries. They store chemical energy, which is absolutely perfect for small, portable things like remote control cars. Oh, and have you ever seen a bicycle light that turns on when you pedal? That is a dynamo in action. It turns your physical movement into electricity. We also use heavy-duty accumulators to start up big car engines, generators that run on fossil fuels, and massive power plants. These power plants use the movement of rushing wind, crashing ocean waves, or flowing water in hydroelectric dams to spin giant turbines. All of these give us that electrical push we need.
Moving on to section 2, meet the circuits, the tale of Sparky the electron.
Okay, let's use our imaginations for a second. Picture an electron named Sparky. First, imagine Sparky running through what we call a series circuit. In a series circuit, Sparky only has one single road to travel on. It's just one chain. So as he runs along this wire, he hits a light bulb, and he has to give it some of his electrical energy. But wait, there's another bulb right behind it on the exact same road. Because Sparky and his electron friends only have this one path, they literally have to share their total energy with every single bulb they pass. By the time they share with everyone, poor Sparky is getting pretty exhausted. And what does that mean? The bulbs get dimmer. A really great example of a series circuit is that old string of cheap holiday lights.
But now, let's look at Sparky in a parallel circuit. This is a total game changer. Instead of just one road, imagine a huge highway that splits off into multiple branching roads that run parallel to each other. Now, Sparky can take the first branch to power one bulb, while his friends take the second branch to power a totally different bulb. Because they all have their own dedicated paths, they don't have to share their energy across one single chain. The total electrical energy flowing through each path is exactly the same. This means every single bulb gets full power and shines super bright. In fact, all those amazing appliances in your house, like the refrigerator, your TV, your bedroom lights, they're all wired in parallel circuits.
Which brings us to section 3, the brightness test, series versus parallel performance.
Let's put this to the test and look at the rules of brightness side by side. If you build a series circuit and keep adding more and more bulbs to that one single wire, what happens? Well, Sparky has to share his energy with even more stops, so the brightness decreases and the bulbs get really dim. It's kind of like trying to share one pizza with 20 people. But if you increase the number of bulbs in a parallel circuit by adding more branching wires, the brightness of the bulbs doesn't change at all. Since each branch gets its own full slice of power from the energy source, every single bulb stays brilliantly bright, no matter how many you add.
All right, section 4, broken circuits. What happens when the path is blocked? Okay, here is the scientific answer to the mystery we talked about at the very beginning of our explainer. In a series circuit, because there is only one road, if a switch is opened or a bulb breaks, the road is literally broken. It becomes an incomplete circuit. Sparky can't jump the gaps, so the electric current stops entirely, and boom, all the bulbs go out. That's exactly why your entire string of holiday lights goes totally dark from just one bad bulb. But in a parallel circuit, if a switch opens on one branch, only the bulb on that specific branch goes out. Sparky and his friends can just detour and continue flowing through the other completed paths. And that is exactly why a broken bulb in your kitchen doesn't stop your bedroom TV from working. Pretty cool, right?
Now for section 5, smart energy and home safety. protecting yourself and your planet.
Electricity is incredibly powerful, which means mishandling it can be super dangerous, leading to electrocution, short circuits, or even fires. So we've got to remember these golden rules. First, never, ever touch electrical switches or appliances with damp or wet hands. Water conducts electricity right into you, and we definitely don't want that. Also, connect only one plug to one socket. Don't overload them or they can overheat. Always turn off the switch before you pull a plug out of the wall. If an appliance is acting funny, don't try to open it up yourself. Let certified personnel repair it. And never use a frayed or damaged wire, because that exposes the electric current and causes really dangerous short circuits.
Aside from playing it safe, you can also be an everyday green hero. Wasting electricity means burning more fossil fuels and spending more money. But you can lower your family's monthly bill and help the planet just by doing a few simple things, like choose a fan instead of the air conditioner on a breezy day. Make sure you switch off lights and appliances when you leave a room or go to sleep. Oh, and when you're getting a snack, don't just stand there with the refrigerator door wide open, letting all the cold air escape. Finally, encourage your parents to use green technology, like energy-saving LED lamps instead of those old, hot filament lamps.
And finally, Section 6, Fun Science, Circuit Quiz. Can you match the facts?
All right, Year 5 scientists. I want you to pause this explainer right now and see if you can pair up the starts and ends of these sentences. We've got some key electricity facts here, and wait a minute. It looks like a rogue biology fact snuck into our physics textbook. Well, let's see if you can solve them all anyway. Go ahead, hit pause and play along.
Welcome back! So let's see how you did. The main source of energy in the ecosystem is the sun. And as we learned today, the crucial point is that if the number of bulbs increases in a parallel circuit, the brightness does not change. Remember, Sparky has all those awesome multiple pathways. And for our sneaky biology bonus, blood carries oxygen, nutrients, and waste products. Great job if you got all three. We've covered so much ground on our electric adventure today, from Sparky's single series paths to the bright, branching roads of parallel circuits. To wrap things up, I want to leave you with this mind reflection. Take a look around the room you're sitting in right now. What is one specific, small change you can make today to save electrical energy and be a green technology hero? Think about it, take action, and keep exploring the amazing science all around you. See you next time.